This conference will now be recorded.
Hello everyone, I'm Jay here. Let us begin. Because I need the privilege for sharing my screen.
Sir, I am making you, sir.
Yeah, yes, sir.
Perfect. That would be great.
So, what you are doing, sir?
Yes, I have received it. So, is it visible? The screen is visible, right?
So you projected on
Sir, visible, sir.
View mode, no?
Perfect. So let's begin. Thank you once again, everyone, for having me. So I'll start. Today, it's not really much like yesterday to talk about because it's purely based on some calculation and basic know-hows. But today's topic would be secure blockchain inheritance and quantum proof cryptography. Now, about the topic, I would like to share that what do I mean by blockchain inheritance? Because nowadays we are witnessing that Gerald Cotton and Richard Graham and all of this big giant tycoon of our industry unfortunately passed away, and they did not have the access management system. So for say, just assume hypothetically that you are a CEO for a biggest crypto exchange or blockchain exchange. Now you are not having that privilege to share your private key with anyone because daily they have more than 50,000 bitcoins worth of transaction, and that is like $500,000. Per hour they are keep on depositing and withdrawing the more than $500,000, I can say. And in general, about their handling $500 million. So you do not have the privilege to share the key with anyone else but yourself and the authorized partner. Now, if something happens to you, then what happens to the cryptocurrency? What happens to that particular asset? Because the way blockchain is formed, no one can take that particular place. No one can authorize for you. So that's why we have come up with some ideas with Bitwill, even the DIY solutions, do it yourself. So I'm going to discuss it today. So now, today's topic, what we will learn, basic cryptographic transaction signing system. I know that you guys are really smart and you know this particular thing, but I will just share it because those who do not know, they will get some basic information. So I will not sound like a nerd today. I will be literally point to point discussing this real life issue that we can learn something and demystify the darkness and lack of support which is not there, like inheritance, the will, the custody-less solution, the pre-signed sharding. These features are not available as such as a core blockchain features or functions, but we can make some tweak that enables us to evolve in that era, that we will be not prone to any kind of these attacks or these unfortunate event, and we do not need to suffer the aftermath or consequence. So let's start with that. Now, the basically we all know about the blockchain. Yesterday also we have heard enough of that, but here is just a quick information about this. So whenever a sender and receiver, this is always, blockchain always is a peer-to-peer. So we have to refer one peer as a sender, another peer as a receiver. Okay. So now, whenever there is a peer-to-peer transaction, whenever there is a transaction between two people, you know what happens? First, as we all know, we have to authenticate, we have to verify. So the sender takes unique, first of all, both of the party have to generate the compatible wallet. So first generation phase happened, a unique key pair is being generated. In the second phase, receiver have to share their public key to the sender. And once the data is shared, what sender will do is they will input the amount or the details for the transaction, and they will put the public key of a receiver. Suppose you are a receiver and I am a sender, then I will put your public key. And to authorize that I am actually the authority, I am the owner of the wallet, what I will do? I will put my private key to sign and authenticate this particular transaction. And that's how the digital signature in blockchain is generated. Now, once on the phase 3, digital signature is generated, it will be hashed and encrypted, and then it will be broadcasted. Broadcasted where? Yesterday I have shared something about node and super nodes, right? It will broadcast it with the nodes, and then the miner will come in, and then they will verify and decrypt and validate the transaction. And at the end, once the miner verifies the transaction, the end transaction is being received. It's the whole barter is completed. So receiver can go to any of the block explorer, and in this particular block explorer, he have to type this particular transaction record, the transaction ID or their public key. So with that, they can see whatever the confirmation is done, what is the amount of the transaction, everything will be listed over there. So this is basic transaction signing system. This how the whole crypto system works. Now let's switch to the PSK infrastructure and private public key infrastructure. So as earlier we have mentioned that the Bitcoin is basically working in the ECDSA, elliptic curve digital signature algorithm. So based on the elliptic curve, the PSK infrastructure, I can say private key is being generated, but it's not like you just take any point on the curve and that random key will be the catalyst to generate the private key. See, you have to insert a certain amount of random entropy. Based on that random entropy, the hashing function will calculate and then concise that particular thing into a private key. Once you have a private key, it will again concise into the public key. So here is a bit of explanation with ECDSA. What are the different elements? As I say, private key is just a secret number for those who don't know, known only to the person that generated it, because it's a private key. A private key can, with that particular private key, you can access the account. And unlike the banking, as I said earlier, there are no KYC involved. There is no other central authority involved. So with just private key, you can take out the funds. Okay. So make sure that you don't share private key with anyone. But what this private key consists of? We have, this is getting so redundant that I have shared that whole infrastructure and ATMs and everything and the wallets yesterday. But why it is keep on getting again and again? Now this time, I'm not going to talk about the hardware part of it. I'm going to talk about the forensics of it. Means what actually does have. What is a private key? Private key is a 256-bit integer. Okay, it's like there are it's basically 256-bit string with which it has to be hashed into a public key. So a number that corresponds to the private key but does not need to be kept secret, that is called public key, because public key is calculated from private key. But you cannot actually reverse it. You cannot do vice versa. Like once you have a public key, it is almost impossible according to the mathematical theory to go reverse and then calculate the private key. So this compressed public keys are 33 bytes consisting of prefix either 0 into 02 or 0 to 03 and 256-bit integer called X. The older uncompressed keys are 65 bytes consisting of constant prefix 0 into 04, 0x04, followed by 256-bit integer called X and Y. 2 into 32 bits, so for sure. The prefix of compressed key allowed Y value to be derived from X value. So basically what this is trying to say is very simple. It's just a mathematical function. So once you calculate it and hash it, you cannot go reverse from private key. See, you have to picture that from ECDS and nonces, from the entropies, you're creating a private key. From a private key, you're creating a public key. And I assume that you also remember about the seed that yesterday I have shared. Do you remember about the Bitcoin improvement proposal and protocols, BIP 39, BIP 31, BIP 49? So all of that proposal was like there is a directory of certain words, and from that particular word and hashing use of that particular word and hashing function, the seeds are generated, and from seeds you can also derive the private key and then public key. So make sure that you don't get confused. Now let us get to the point after the public key pair infrastructure to the blockchain inheritance, because today is it's this one is the really important and main topic of today. So, do you know, have you ever thought that what happened to the crypto asset upon the untimely death of the wallet holder, or maybe your wallet is broken or it's not accessible and you have not backed up anywhere? It's going to be disaster because it's unlike banks. There is no central authority. If there is no authentication mechanism available, there won't be any authenticity. There won't be anyone else in your proxy or in your behalf to authenticate that and take out the funds. So the funds will be there on the blockchain in your Bitcoin wallet, but they will not be accessible. So now, because of ECDS encryption, once the key or owner is no more, the funds cannot be transferred from blockchain. You see, this is a bless. I mean, I can say that this is a really good blessing that no one else can take power of my wallet, but then at the same time, this is a curse that if I lose the authentication, everything is done and dusted. So let us look at some case studies as well. Let me open up the first link and I'll share the tremendous amount of loss that we are suffering from, and that's kind of okay with the deflative economy, but then it's really not good for the people who lost it, because see, 50 Bitcoin per block of every 210,000 block, right? Every 210,000 block, there's a halving. We have been through that. Now, because of this, see, they have proven that this particular transaction in this particular things from Genesis coin duplicate coin transaction, we have lost approximately this amount of Bitcoin. See, some of them are unclaimed reward. You see, now if I convert this into Indian rupees, you can only imagine what's going to be, because one Bitcoin is around 7,10,000 Indian rupees. So lakhs of crores of rupees, unprecedentedly, because of some mistakes, it's lost. See, so I will also share some other things. Now, there are different sectors in this swing, but currently, as per this data, more than 10 lakh Bitcoin have already lost because of loss of wallet, or I can say damaging of wallet, or not a proper deployment of access management solution. But there is something more crucial that I just told you about. You see, some time ago, some months ago, uh, the Quadruga CX exchanges owner, Gerald Cotton, the CEO, passed away. And I will share how much. See, $250 million worth of cryptos were in there in the account. And it's really questionable that even the biggest exchange in Canada, they have to shut down because of their CEO is no more, and there was no amount of access management was done. So here I'm not just trying to promote Bitwill or anything else, but these are the serious concern. Just before that, $500 million in Ripple lost Lost means it is just there in the blockchain account, but no one can access it because the owner is dead. The Matthew Mellon passed away in Mexico out of a heart attack, and 500 million is frozen. So what did we learn from this case studies? We have learned that, see, first of all, we have to admit that blockchain gave us a lot of liberty. Just like I said, I'm a crypto citizen. That means that I live on Bitcoins. Just like that, there will be many of you guys who are very excited to invest in that, who are very excited to go about that, even not just for a monetary value, but there are a lot of things like supply chain is on the Bitcoins, authentication mechanism is on Bitcoins. There is a civic portal is on Bitcoin in Estonia and Scandinavia and all the different countries, as well as there are voting portal also. They are currently beta testing Swiss and Estonian government. I was a very tiny part of it. So when I was in DEF CON, so that's how I got to know about these things, that everything is being tokenized in a blockchain. And if you have your own authentication token, which defines you uniquely, which authorize you, if you lose the control of that, then you may lose the identity. It's just like losing your passport. So for that reason, I am seriously sharing this issue, addressing this issue, because all the other knowledge you will get from internet, but this thing is very essential, and I think these are the rudimentary things that we should understand to create proper chain of custody, to create proper inheritance and access management. So let's move to other page. Now, you know the seriousness of this thing. Now, you may ask, hey, can you guide us? What are the best solution for the crypto inheritance? And I would be happy to guide. See, if you are not too tech savvy and if you feel that I can afford some amount because I have a really big amount of investment, or the business is really serious, then you can subscribe to one of the corporate access management companies like Bitwill. We do not take your private key, as I said, and this is how our will contract looks like. So this is very dummy contract, but we provide this kind of thing that ensures the reimbursement after the untimely death of the Bitcoin owner, or if the Bitcoin owner or any the cryptocurrency owner or the crypto asset owner loses their access. So we make sure that we can recover it without even accessing your private key. So that was the smart contract I was talking about. This is the physical version of, there are a lot of things going on the background, like on the server side, but this is what the customer generally get. So this is just a corporate thing. This is just some of the things that we do at Bitwill. But apart from that, I want you to be self-sufficient, because crypto is all about that. Be salvated from all the big corporation, including my company, because I want you to get the power of self-authorizing these things. Making it so available that any Tom, Dick, and Harry can deploy by themselves. So now the DIY solution, how to make your crypto and how to make the inheritance. What are the ways to deploy a secure inheritance to make sure that even if you share it with someone without your proper access, they cannot generally sign the transaction or broadcast it. So one of the best way is make a multi-factor authentication split wallet. Yesterday, do you remember I have shown you yesterday that we can create like M of N signature, like we can create 3 wallets, and we can set the rule where 2 of them can have to sign the transaction in terms of putting the funds out of the account. So that is one way to do it. And then what you can do is you can create multi-factor authentication and then distribute amongst your family member, like your wife, your son, your daughter, your parents, and then you can set, and even you can give one to your will executor or your attorney, that upon any unprecedented thing or any untimely thing, no one has to bear the loss consequences of not managing the access of your customers. So that is really one thing that I would like to share, that do put this multi-factor authentication that will literally help you to have a distributed access management. Now the other solution is the wonderful solution if you do not want to go for M of N signature. Suppose you have a Bitcoin wallet or any other cryptocurrency wallet. Bitcoin is a generic, very widely used. So again, that's why I'm using Bitcoin. So pardon me. This is definitely a blockchain enlightenment, but Bitcoin is the core of it, I can say, because it's very easy to comprehend. So for that reason, I'm using Bitcoin as a illustration. So for say you have a Bitcoin wallet. Now you have 5 Bitcoins on it as per today. So what's going to happen is you do not need to do any kind of multi-factor authentication as the other solution goes. What we can do is you can generate one empty wallet for your wife, your parents, or your nominee who are supposed to be beneficiaries. Okay. Now, that particular wallet's public key, not the private key I am saying, but public key, you should take it, you should feed into that input output mechanism while signing the transaction. You pre-sign the transaction. Pre-sign the transaction means whenever, do you remember yesterday I have shared that how the transaction is initiated and then it is signed and then it is broadcasted to the nodes. Here you just need to sign the transaction, keep a copy with you, and share that particular copy with your family members. Do not broadcast it. Broadcast means you upload it to the internet. What I'm saying is do not do that. Skip that step. So what's going to happen? You will have 5 Bitcoins in your wallet. It will not, it is just like a pre-signed check that I'm pre-signing check of 5,000 Indian rupees from my bank and I'm giving it to you. Now, if you go to the bank and redeem the check, only then the account balance will be affected. But without that, your balance will stay intact. So suppose today I am going somewhere, I'm traveling out of country, and I'm traveling by air. So now there may be some risk involved to that, in the travel. So what I would do is whatever the remaining balance I have, I will pre-sign the transaction. I will make that transaction. I will make the copy of it. I will give one transaction copy to my lawyer, one transaction copy to my family. Now, you may have this question that, hey, Jay, you know what? What if I give the transaction and they execute the transaction? What's going to happen then? Now, first of all, the signed transaction cannot be altered. So even though someone get the transaction, even the transaction copy is leaked, they cannot alter the address. So it has to go to your nominee. Now, if the nominee is a bad actor, let's say for the worst scenario, the nominee is a bad actor. So you should also keep the private key of that particular inheritance wallet. So if anyway your wallet gets emptied or any unauthorized transaction happen, you already have the control over that remittance wallet, so you can take your funds back, you see. So we have to be little bit aware and active to manage our inheritance. Now I will share the section, the non-dependent section of it. You can be a self-dependent, just like yesterday I have shared this thing, I'm sharing it again. So if you want to generate a multi-factor wallet, these are the bit address. So see, here is my mouse cursor, see the pointer is moving, and beneath that, because in the quantum computing this will help. So basically just observe this. Whenever my mouse moves, there is a section which insert the nonces, or I can say the entropy. See, the random strings has been inserted. So whenever the entropy is fed, there will be the randomness into the calculation. And then because of the randomness, the entropy makes sure that if you are generating, if I'm generating, if Mr. ABC is generating, we do not generate the same wallet, because then it will be a collusion, and it will be a big interference. So now you go to bulk wallet. Sorry. You go to split wallet. My bad. So now suppose you have a 5 family member and you are saying that only any 3 family member have to sign in terms of executing. So you can generate number of share is 5. And minimum share threshold need to be combined is 3. So now see, share 1, 2, 3, 4, and 5 is generated. This is, see, first of all you have to know that what are these things, share and Bitcoin address. Bitcoin address is your receiving address. In this particular address we can receive the funds, and once you receive the funds on this address, now if you want to spend the funds, what's going to happen? With this particular key or that particular key, just one key, it cannot happen, because here you have set up a constraint. And what is that constraint? That five of any three guys have to share their authentication. So without sharing a private key, what you should do is, once you get the hex code of transaction, you will combine the shares, like this share. See here, share number 1 is there. Maybe let's take share number 5 with the space, and anything, share number 3. Okay, see, once you combine, this is your private key. But if I remove this one, see, there will be no private key generated, because it does not have sufficient amount of MOVN signature. Like how it works is, there is a, it just works like a RAID system. If you know about the RAID computer system, where there is a hard drive 1, 2, and 3, and the data has been sharded in a way that if any of one hard drive withdraws and fails, from 1 and 2, 3 can generate, 2 and 3, 1 can generate, and 1 and 2, 3 can generate. So it's just like A, B, and C. With any two combination, the third one can be generated, because it has a partial data of both of the drives. So this how it works. This how MFN signature, I can say, or split wallet generally work. Now the other thing, the other hack I would like to share is, you can also do some kind of tweak in, I can say, see, brain wallet. What you should do is, you can generate some password, and then, just a minute, see, this is your passphrase. Now this is what you have generated. So you can take this public key, and you can put the passphrase into this will system, that whenever the will is being executed, you can just write down the steps, that how to generate this particular address. So see, that's just one hack which I found, apart from these two method of inheritance. And the other thing I would like to share is pre-signed transaction, as I said. Now, how one can generate the pre-signed transaction, right? So all it takes is very simple. See, here you have to insert, first of all, this is a website. So never ever go to the website, never do this thing online. What we should do rather is, go to offline, or here you can download the source code. Go fully offline to make sure that we trust no one. No one can actually screw us up, or no one can hack or leak our data, being man in the middle, right? So what we should do is just go offline. Even if I go offline, right, I mean, obviously the conference is gonna get end, but even I go offline, the script is already loaded on my laptop, so there'll be no change. Here I will type my private key, here I will put my hex, and then I'll submit. So once I submit, the transaction will be generated, and that particular generated transaction I will just copy and make a text file of it, and then give it to my lawyer, give it to my family, and then whenever the time of execution comes, I will just paste the hex in here and then submit it. So once I submit, the transaction will be broadcasted with the particular nodes, and once the nodes capture this, the whole mining thing, and then, I mean, in short, the funds will be reimbursed. So I think these two links would be more than enough for you to be self-sufficient and get your access management in the correct direction. So that would be, I guess, it for the part of inheritance. There is little nothing much to elaborate on that one. If anyone have the question on inheritance, or how you can do it, I would be more than happy to answer that. Do ping on the chat, or do send me the mail. Once again, I will share my email with you, jay@bitwill.com. So our first thing, the inheritance part of it, is pretty much completed, because it's very simple thing. It's not a rocket science at all. So I hope you guys can understand well, and thanks a lot for tolerating me for the first part. Now let's move on to the second part. If you remember, I have just shared that the random entropy was generated, and whenever the random entropy is generated, the private key is calculated from that, and then so on, the whole story. Now, my question to everyone is, we all know about the computers, like there is a rand function. When the rand function is activated, there will be two randomness, and the calculative randomness and processing randomness will be generated and all of that. But let me ask you one question. How random is randomness? Not asking you philosophically, literally, how random is randomness? Because is it possible that my computer and some computer in Australia or somewhere else generate the same random code on different time? But maybe, why not? So whenever two different systems generate the same amount of entropy, which is really less likely, but there are certain ways to go about that. I will explain it. That is called as collusion. So whenever you have multiple wallets, and sometime, very rarely, your system generates the same amount of entropy that the other system is generating, sooner or later you will both going to be end up in same key pair. You will both hold the same key pair. If I have ABC, you're gonna have the same ABC. So if I put money into that account, you're gonna, you will have the privilege to take them out. If you insert it, I will have the privilege to withdraw them. So that's called collusion. Now, the thing is that in theory they're saying it's okay, but we are now reaching to the era of supercomputation power, whereas the quantum computer is already been introduced with by, I guess, IBM, Google, even Apple is trying to do something about that. And recently I got the news that Honeywell, one of the big giant company, Honeywell, they are into the security, and they also got the quantum power more faster than Google. So do you think that collusion will be obsoleted, like literally cannot be possible or cannot be applied with the quantum mechanics? So the odds, so according to this calculation, the odds in colluding with a specific address. So suppose I have address 1, 2, 3, 4, 5, 6, 7, 8, 9, ABC. So this is my address. So this particular address has to go through, I mean, exponentially higher amount of generation. Like you can see this. I mean, 2 raised to 160 um, is a ratio of getting one specific address. That's the power of entropy. And that's why currently the Bitcoin system and blockchain system is intact. So according to the calculation, he's saying that if there are a billion users and each user have 1 million active addresses, then 1 quadrillion funded addresses in the blockchain. The odds in colliding with any address would roughly be 1 in 2 raised to 110. It is really a big probability, And vanity gen can produce 20 million key pairs per second. Yes, I know that, because what they are, so basically, there are some people, I can say crypto pirates, I used to refer them. So they buy this high powered machines. Even some of them are doing this Raspberry Pi and Arduino and all of the different circuitries cluster, and all they do is they don't make node out of them, their devices. They do not make the hardware wallet after the devices. What they do is very simple. They will keep on generating addresses. So someday they think that I will get some lottery, that if this particular address have some balance into it, we may get lucky. They keep on generating the addresses, keep on generating the addresses, and let's see. I mean, there was some data that there is a project going on called LBC, Large Bitcoin Collider, and they literally deliberately tried to collude it. And I will share the link as well. And they got succeeded as well, but not with all of the address. Very minimum address, like 115 Bitcoin worth of address. The other was 5, and then other was 0.05, something like that. Very minuscule. Other two was really big deal, but the third one was very minuscule. But still, it's not impossible. That's what I was trying to convey. So basically, let's say that you build a super ASIC on 12 nanometer. Like, this is what I'm about to say. I mean, 4 generation ahead of the current tech. So we are hypothetically assuming the scenario that let us build a super ASIC computer on 12 nanometer, like 4 generation ahead of this particular technology. But it is not a quantum one. It is just like a supercomputing power, where else it's the same mechanism, 1 and 0. So that process could create, validate, and steal 1 trillion key pair per second. So 1 TK per second is the hash rate. That would be 50,000 times more powerful than faster GPU today. So let's also say you built, I mean, if there are 1 quadrillion funded address, and you would have around 1% of chances of colluding with a random funded address in next 1000 years. You see the power. You see the power of entropy. Well, you know what? I have read this. I sound like a nerd. Okay, he's a bookish guy. But let's do one thing. Let me show you some shocking thing, because this is a theory and I do not oppose this. This theory is really good, but mathematics and statistics have their own pros and cons. So let me open some really gibberish and funny project. This project is known as key.lol. Now let us generate a fresh wallet. So no other guys can have this particular database. Let us generate a fresh wallet. Okay, a very fresh wallet. Okay, so now this is a fresh wallet we have generated. Let us copy the key. Let us try to search. First of all, I would like to share about this project, key.lol. What this project is all about is, just like I said, these guys are buying like bunch of computers, high power computers, and they are keep on generating and generating and generating addresses. So what these guys are saying, a private key is basically just a number between 1 and 2 raised to 256. The website generate keys for all of those numbers spread out over the pages of 128 key each. So let's see how it goes. Oh yes, I am a human. I am the one who made it. Hey, pardon me, I'm being funny. So now look at this. Look at this number. Can you even comprehend this thing? This many pages they have. And what did I say just now? I'll share again. Each page have 128 keys. So quadrillion like wallets are generated already. And I mean, pages are generated, not the wallet. And each page contains more than 100 keys, you see. And these guys also have checking mechanism that whether this transaction or this particular wallet have 1 Bitcoin or any amount of Bitcoins or not. If they do, here is your private key, here is your public key. You're gonna take it out. See. So now you understood what I have said, that if you make a deliberate effort, and if there is a decentralized effort and everyone goes crazy towards this particular thing, because that was a tactic of one computer. The other data was just sharing that if we are having a 4 generation advanced computer chipset and supercomputer and all, but it is about a one computer. It's not about the collaborative approach. These guys are making a collaborative approach. See, now the page number, I can put any other page number and see random page number, and this page will open. So every page contain different kind of keys. You see, it's not the same. Every key has different thing. So now back to the topic. Can we search? Just now we have generated this key. So can we search that whether this key is already generated or not? Because see, this website and this website are different. This website generates key basically offline. Online is just a website, but then once the online website is loaded, there is no server side communication. Okay, you can even try to do it offline and you'll find the same solution. See, so I have pasted the key and I will search it. And here we go. Control F, and then I will search for the key. See, here we go. See, shocking, right? It's so scary also that all the possible keys has been generated by one company. Like it's really a scary thing. But that's how it is, you know. That's why I would like to enlighten you and open the eyes, demystify all of the gibberish theory fallacies that sometimes do not work. Okay, I'm not saying that theory is all wrong. It's definitely there are no chances of collusion, but there are different types of wallet. You know, HD wallet is there, SegWit is there, and different derivations and different kind of mechanism. And if you have enough power, if you have enough community support, then I don't think anything is impossible. You see, this is our address. You see, 173. It's a public key also, 173 NW. See, same thing. So this guy's already got the, see, I will generate some address and then randomly copy the private key. See, now I have copied the private, just a minute. Wait, let me copy it from here. So it's a new generated address. Now let me search in here. The page is open. Where is my key? Ah, here we found it. See, the public address 1QIC. So that's why I always say that how random is randomness, you know. But you do not need to worry about this, because as I said, with the brain wallet, what you could do is you can put your own set of rules, own set of mnemonic on top of this. So you make sure that it's not very predictable, it's something random. So that's what we have tested it with key.lol and by generating a new wallet. Now, this is a very interesting work. This is what I was talking about. Oopsie daisy, what happened? Large Bitcoin collider. Okay, here we go. So these guys are the one who have made the client for that. You have to install the client in your device. And once the client is installed, you can start collating. These guys were a bit successful in 3 wallets, and then there are no success yet. It's a long project, but still, this guys will show you the power of collaborative approach and teamwork, where you do the, you connect to this particular node and then you're trying to brute force this mechanics, you see. So yeah, people do have power. So yeah, this is the last Bitcoin collider. Now let us switch to the other thing, the wonderful favorite topic amongst everyone, the quantum computers. Now we have different kind of chipsets nowadays. Like we have Intel, we have AMD chipset. All of these chipset, right? All of these computing power is being conducted with just binary things, 1 and 0. Our classical computers carry out logical operation using a definite position of a physical state. Okay, the switching state. Now this state either will be on, either will be off. Usually, what happens is the operation are based on one of two position. Either it will be position 1, either it will be position 0, either it will be position on or off. So basically, in quantum computing, we have data bytes and beats. In the classical computer, we have this thing, but in quantum computer, we have qubits, quantum bits. And the tremendous power of quantum bits is it can be 0 and 1 at the same time. Like the quantum state is like it can be 0 and 1 at the same time. So it will be, I mean, even if you can compare normal quantum computer and very high budget supercomputer, quantum computer will achieve more than a supercomputer. It will definitely better benchmark and better in performance, because once the matter is 0 and 1 in the same state, it has tremendous amount of potential for calculational I can say problem solving mechanics or algorithm or competition. So quantum computers perform calculation based on the probability of an object's state before it is measured. So instead of just 1 or 0, they have potential to process exponentially. See, that's what I said. So it's a really big thing. It's really a big deal, and we should start worrying about the quantum computing from today. And I'll share you why. I'm not trying to put chaos in here, or I'm not literally trying to spread some, you know, uh, issues or depression in here. All I'm trying is we guys open our eyes and get to know about the world, what is happening, how it can affect each one of us, and what we can do to make sure that does not affect us. Now, the thing about quantum computer is, first of all, there will be a big disparity in the society above this theory and above everything, because quantum computer, like to make a quantum chipset, it's a really very expensive at first. So generally not and like you and me cannot possess that. A normal user can never be able to possess that because of two things: money, I mean there are costs involved, and the other thing is the infrastructure, because you need tons of infrastructure and manufacturing capacity to get it done, and then you have to have the money also. So those who have quantum computers will be a quantum supremacist. Like they can break an interaction or any kind of transaction for the bank, and for say defense protocols, or I can say any kind of big highly sensitive information. They can break it by quantum computing, and within just what, the password which takes years to break. I will also share something. There is a website which shares that how prone proof is a password, how strong is my password, see, or how secure is my password. So this is a password strength meter. Okay, here I will put this Bitcoin private key. So for a normal computer, if my computer start breaking this, what time it's gonna take? It's gonna take more than 20 trillion years. So this is the ultimate secure key. But whenever you get exponential amount of data and processing unit, it just decimates like this. So I will prove that. Definitely I have some theory onto that as well, so I will definitely share. So the quantum computing, the operation instead use a quantum state of the matter. So this qubit, right, the state are very undefined, that there is no 1 or 0 predefined property. Even the quantum clocks, right, once it's been set, it cannot even be I can say cloned to know what was the previous state or something. So you cannot even clone the qubits. So now there is a spin. How it's a very analogics based. So quantum computing, again, I would like to say that not just 0 and 1 as a digital state, but the quantum state is a bridge between digital and analogics. So this also has an analogic. Why analogic? Because it has electronic spin. So rather than having a clear position, there is an unmeasured quantum state occurred in the mixed superposition, unlike coin spinning through an air before it lands in your hand. This superposition can be entangled with those of other subject or other objects, meaning the final outcome will be mathematically related, even if you don't know what the state are there. So for say there are two qubits, okay, you do not know the state of one and two qubit. Okay, there is A and B, two qubits, but still there'll be quantum entanglement between these two that give you very calculative, very definitive answer, even though you do not know the state. So now you can just imagine that the complex mathematics behind the unsettled states of entangled spinning coins can be plugged into special algorithms to make short work of problems that would take classical computer very long time to work out if they could ever calculate them all. Because classical computers like currently NASA and all, they are using the supercomputers, but still some calculation which have a very much precision like 0.0000000, like picometer precision. With the quantum you will get the finest precision a mankind can ever receive ever reach. So such algorithms would be useful in solving the complex mathematical problems, and they can produce hard to break security codes on predicting multiple particle interaction in chemical reaction as well, just like analogics does. Analogics is not one and zero, it's a sine wave. So the spectrum of that is very big, just like that qubits spectrum is very big because of the quantum spin. That's what it's happening with the qubits. Now let us talk about the quantum computing supremacy, because with the great power comes a great responsibility, or rather I can say that with the great power comes a great ego. So for the time being, classical technology can manage any task thrown at a quantum computer. Quantum supremacy describes the ability of quantum computer to outperform the classical counterpart. That means, as I said, the biggest disparity within the common class and the elite class would be this, that the elite one would have quantum supremacy. We guys will be nothing. Like, we will not have quantum computers in your Dell or HP or MacBook, because it's going to cost you a fortune. So nothing will be secured, and if you try to secure with another computer, then, as they say, vice versa, they say that the more guards you pull up, the more guns they will pile up to break that guard down. So there is always a countermeasure for that, but then there is always intrusive arts. That's what I've learned in the cybersecurity, that even the quantum cannot be an ultimate state, because see, whatever can be calculated can be derived. That is very simple psychological hypothesis, or I can say mathematical hypothesis, that if at one point currently we have a quantum perception, which is the smallest perception we can create, but in future with the quantum enabled thing we get more and more power, and we maybe we can do something about boson particle and then the other particles. Let's see if we can do something about the quarks and even go more minuscule than this, and the quantum may be decimated and defeated. So we never know. So there is no silver bullet of it, but I would like to share some light that, as I said earlier, IBM and Google are claiming to be close to continue to cram more and more qubits together and build more accurate devices, the quantum calculative devices. Now, I'll tell you something. There are literally a new news line coming on by the Honeywell on the quantum computing era. See, Honeywell's new quantum computer edges closer to threatening the Bitcoin. So Honeywell has somehow managed to put really big amount of qubits together. See, 64 twice as powerful as rival IBM and Google. And quantum computer can theoretically be used to attack Bitcoin, although the crypto community is preparing defense. That's what the decrypt is saying, you know. But let me share one more thing. This is another 6-qubit quantum computers. So news.bitcoin is one really informative forums for the crypto community. See, breaking Bitcoin, crypto proponents discuss Honeywell's 6-qubit quantum computers. See, so this is what it looks like, the quantum computer, literally, because it has to, so the quantum computer take a lot of heat, so it requires a proper thermal cooling. So for that reason, it was encapsulated in the box. Now, I would like, again, I'm repeating this, but there are mnemonic seed, right? Now, with the quantum computing, it will decimate the power of encryption. It will decimate all of that thing that we used to refer to as secure. So with this particular thing, let us try to go back and understand the different architecture which the blockchain has. You know, there is an architecture of mnemonic. There is an architecture of public-private key. Like without mnemonics, there is just a single string of public key and private key that you used to define, right? But if you even talk about the mnemonics, for say that PSK is really good and RSA is also good, but most of the wallets, HD wallet that you have, the Elipal I shown yesterday, the Ledger, Treasure, Keep Key, majority of the wallet, right? They use this mnemonics. They do support the mnemonics. So here they are saying that the word list for BIP39 contains 2048 words. So in order to crack a 12-word phrase, it would require figuring out 2048 raised to 12. It means 2 raised to 132, a possible combination. You know, there are a lot of zeros as per now, because we do not have the quantum supremacy yet. But do you think that if the quantum bits, which can be 0 and 1 at the same time, have exponential power? See, these are the exponential prediction. These are the exponential randomness. To defeat the exponential randomness, we will have exponential power, exponential amount of power to defeat these kind of things. So then, I mean, what makes you think? You look at the seed, body, decision, painful, space, bloom, sunlight, grow, wean, soon, sorry, sun, third, mirror, dance. All of these seed, these are basic dictionary word. So I can do the directory traversal attack towards this. Beat BIP 32, 44, 49, 84, anything, any amount of seed for a quantum computer. This is a peanuts. It is just like you know, cutting a cake. So basically, how to prevent yourself from that? I mean, I do have something that we can illustrate in person, and I will share my research. Like, I am researching this quantum proof mechanism from last 2 years, and that's what I refer to as cryptonics. Now the whole cryptonics concept will go under the patenting process, so for that reason I will have to share very limited sense of things, but that does not mean that I am keeping it hush hush. I'll definitely be very proud to share this particular thing. So let me share my quantum proof mechanism. That was the main topic for today, and I would not delay that any further. So let me set up an environment where I can basically interact with the system, and I can just do it right now. So let me switch to the Miro. See, now everyone has to pay attention, and this has to be more interactive than you have ever expected. See, Okay, so this is the whiteboard for me. Now, if I say quantum proof mechanism, you will have a question that, hey Jay, you know what? Quantum can calculate anything, so you have to beat quantum with quantum. Yes, agree, but that will be really not cost effective for me because I cannot afford a quantum computer. But if I were to say that, hey, you know what? I have developed a mechanism which requires no quantum computation. I mean, with a very, I can say 7,000 Indian rupee worth of Raspberry Pi with 2 GBs of RAM can beat the quantum computer with a proper set of calculation. And you'll think that as a miracle. I'm not promising you moons and stars. It is very basic. It is very basic power of mathematics, and I'll show you how. So let us begin that. Okay, here we have to go through a lot of things. Here we have to define some of the variables. Okay, so just a moment. Let me define some variables in here. I'm drawing it out, so just be a little patient with me. Okay, we are focused. Here we go. So to make our quantum proof solution, first of all, let us put some variables on the board. So this is n. Now this variable n is a number. Okay, it can be real number, it can be anything. It can be 1.3, it can be 1, it can be 2, it can be 198265543, anything. So the n is equal to set of numbers. It can be real number as well. It can be anything. You don't worry about that. Okay, it can be whole number, it can be real number, any number would do. For 1, 2, 3, 5.5 up to infinity. Any amount of number can be a set of n. So first we have n. At the second thing, let us derive the another variable. Now the other variable would be calculation. CALC. Now CALC means calculation which can derive, pardon my handwriting, but actually this has to be done like this, because I cannot just make a presentation about this because I have to do it live to make sure that I illustrate everything. So literally, if you're struggling, so sorry for that. Let me turn off the smart drawing. Okay, now no more interruption. So CALC is a calculation which can derive n. So for an example, let's take a example illustration. Okay, n is equal to 2. Okay, so what can be calc? Calc can be anything which makes 2, like plus, minus, percentage, into, divided by, anything which makes 2 is calc. Okay, so in the other term, if I have to derive this calc, I can say that calc is equal to 1 plus 1 is equal to n, because n is 2. So it has to be calc is equal to n. Understood? So now n belongs to n. So basically, I will share very simple thing. I will ask you guys very simple question. Okay, if your selected number n is 2, if n is 2 for say, what are the possibilities? So now let us take another variable called probability. Prob is probability to derive the variable calci. So if I ask you the question that, hey, can you share what are the possibility to derive 2? I will say that my n is 2, so my calci would be 1 plus 1. Another one, if I ask any other person, they will say 2 into 2, 2 into 1 will be 2. This also will be 2. Someone will say, hey, 4 minus 2 will be also 2. So this all are valid calci. The calci variable, this particular function is valid until it fulfills this particular condition. Whatever calculation you do, it has to derive 2. At any cost, it has to derive n. N should be an answer. Okay. So with all of that, let's move further. Now, the very simple question I would like to ask was, if for say my n is 2, then what is a probability to derive n? And the answer would be, the magical answer would be infinity. Why infinity? Because 1 plus 1 can be 2, 2 into 1 can be 2, 2 billion, 2 minus 2 billion also can be 2. So there are no finite set. There are no finite set to derive 2. Do we have any finite amount of set that, hey, there are only 100 mechanism in maths to derive 2? No, right? There is an infinite amount of possibility to derive 2. There are infinite amount of mathematical equation that can derive 2. Square root with what not. I can use some logarithms and do some complex calculation. So I have taken this calculation very simply because to make it understandable with the pen and paper. If I make automation functions in a software, the calculation can go like crazy. It can go as complex as you want. So let's take one step forward into this, how this can be used into quantum proof encryption mechanism. So first of all, we have to select n. So sorry about this. We have to select n. Select n. Now you can select n, or your computer with the rand function can select n. Now then you have to perform CALC, the calculation which derives the n. Okay. So now here I'm taking n as 7. For say, let's take n as 7 or any random number. Okay, it doesn't matter. So n is equal to 7. Let's perform the calculation. 3, 0 plus 1 minus 1 plus 1 minus 1. See, is equal to 7 for say. So this is matching. Now 7 is derived. So that means the calci is a valid input. Okay. Now, very simply, I would like to share that this is your unique number. This is 7 because it's not unique, like everyone knows 7. But what if it is 19823569857248663? You cannot, no one can imagine the same thing, right? If it is, for say, if it is like 100,000 characters long, you cannot imagine that. It's a hell of a lot of entropy. So this will be unique function. This will be also unique function, because if I were to say that, hey, you know what, think about any number, real number, whatever number you want to do, integer, float, you can think of any number, and then you can think of any calculation to derive that number. And there what are the chances that I can predict that? Because the answer, see, the very basic thing is here we are dealing with the infinity. And I know that some people will say that, hey, you know what? Uh, L'Hopital rule is already there. L'Hopital rule is saying that 0 divided by 0 also it's an undefinited equation, but it can be definited. Like I do have a link for that as well. See, L'Hopital rule or L'Hopital rule, whatever it is, there is a method with the limit. You can actually define the finite equation from undefined, right? I know that. But here there is no set, there is no finite set, there is no finite limitation. There's the first thing we have to understand, that this particular n can be derived from any amount of equation. So how we will implement in a blockchain, now that's a question. So first of all, this is a very naked entropy, so this is very open entropy, so we have to encapsulate it somehow, right? So we have to hash it. So I can name it hash a1. Hash of n is a1, hash function of n. And you know about the hash function, once you encapsulate something into hash, it cannot be reversed. Just like you can make a public key out of private key, but you cannot make a private key out of public key, right? You can make curd out of milk, but you cannot make, you cannot go back. I cannot have buttermilk and then I cannot make milk, because the reversible, it's irreversible process. You understand? So now the n is a hash a1 and this is a hash a2. So we have kept two hashes. Okay. Now both hashes combine, both file, both string. This the hash string will combine and make hash b. So if I want to say that this particular thing will be a unique identifier of your public key, I can say, then to derive the public key, first you have to select the n, which is a really highly random. You have to hash it. Again, you're putting more entropy into it. You have to perform the calculation, which is again so random. You have to put the hash, and then both hash has to combine in another hash, and the hash b will be your public key. So now you already got your public key. Now what will be your private key? The hash will be your private key. This a1 and a2 will be your private key. So basically what we are trying to do over here is the nonces are so much predictable with the binary system that have a finite set. Finite set means, just I said, in this particular thing, see, even this seed have a limitation. There is a finite set, whatever, however big it is, but there is a finite set. And as when it comes to the quantum computing, no amount of finite set can delay, because quantum computing is literally fast enough to betray and drag to dust this binary system. And as per the previous data, see, this is also finite, like 1 in 2 is to 160. Nothing for quantum computing, it's a peanuts for them. Okay. And yes, I do have one literal logical debate. People will say that, hey, you know what, but it requires a lot of power. It requires a lot of resources to get to that level to break it. But I'm not talking about me and you. I'm talking about the governance level, where they have a nuclear power center to power this quantum computer, and a government amount of funding to leak any amount of secret. Do you think that your RSA encryption or ECDSA encryption will be sufficient enough? So here is what I propose. I propose very simple solution. Again, let us reiterate. In very simple terms, I would like to share this with you. That let us assume that there is a very random number n. Okay. Now this n can be anything. Like this n can be 8. How I got this n is 4 plus 4. There are now here the main thing is, I will ask you a very simple question. How you got the 8? So the answer, what are the probability? Answer is infinity, because there is no definitive set which can say that, hey, you know what, this is the only truth or that is the only truth. The truth can be anything which has to define the infinity part of it. Understand? So basically, if the set is infinite, then doesn't matter how big computing power it is, there is a starting. See, whenever you have to brute force, right, there is a starting point. Starting point means, suppose I have some password like 1289, then my computer will start from 0000 0001 0100 0101. Like they'll try all this, then 1111 2222, all of that combination which are basically possible. Okay, so by then they will come to the conclusion 1289. That's a brute forcing attack. That's what quantum computers can do: predict directly routes and brute force the finite set. But what is infinity? They cannot even touch it, because no amount of power can define where to start. I mean, if I say that, let's take one calculation. Okay, my answer would be 8. Okay, I have to derive 8. 1 plus okay, plus minus, let's take some random into 2. See, this is the number. Okay, this is my number. Now what I have to do is to derive 8 plus 8 minus this. See, the answer is 8. So this particular thing, the whole thing, I will copy and make a hash out of it. So I would like to, chalo, let's make a hash. Let's take MD5 hash. You can take any hash. I just don't want to share our proprietary hash function, because it's gonna be the patent. So because of that, I'm varying myself, but do not mind. The function is very same and similar. It won't affect. So this particular string, which derives the 8, was hashed into this particular thing. So this plus a hash of 8 will combine and make another hash. So hash of 8 is what? See, now can you ever recalculate that what was the earlier thing? See, suppose this is a hash of 8 and this is a hash of the other transaction. This hypothetically, I'm not being very precise over here. Here we have another hash. So that can be your unique identifier for these two strings. So strings need not to be exposed anywhere. Your strings can be your private key. I mean, the calculation can be the private key. Strings can be a medium to provide an entropy for the hashing functions and to derive the public key. So your whole calculation, the hash of whole calculation, will be your private key. And what we can do is we can make a parallel chain. We can make a parallel chain just like this, a parallel ledger, which have all the data. And this ledger I used to refer as a CRISPR, just like a gene technology, that these guys do carry your authenticated hash records and authenticated n of hash. N of hash means, like, your unique derivative and your unique signature with that particular thing. So basically you can use that mechanics also. So just imagine the scenario where you have a smart calculator. Okay, and you have to authenticate yourself. What you have to do is iterate the same calculation. You will log this calculation in some pen drive, some device, and then mask the same calculation in the smart calculator, and that calculator not just will perform the calculation but will also authenticate that calculation, will fetch that particular thing with the node and with the miner, and as well as it will calculate the hash also, and then it will validate that whether you are the person who is inserting this particular thing, or you are not the person who is inserting this. Now let's go even further. If I'm not actually boring you guys, because this is very maths is something like that. It's very talkative and you have a lot of numbers and it's very gibberish. So sorry, I'm not able to put it into any more discipline because it has to go through the patterns and all of that, so I cannot share the essential of it, but I would love to share the overall idea because I think sharing is something which I love. And but I also have some paperwork done with the company and some commitment with my company, so I think we can respect that. But without breaking any of that agreement, I would like to share that how to derive this particular equation. Have infinite amount of set, so need not to worry about any kind of predictive measure, any kind of predictive mechanism. Now, to make sure that you and me, my calculation, your calculation never collide, this is the solution which I have built. See, now that is a wallet. In this wallet, whenever you generate this n, right, n can be generated truly randomly, or you can just select, just like a brain wallet. If you do not want a computer to put the nonce, you can directly put the entropy and generate the n. So once the n is generated, it will go through this particular thing, which is Kelsey function, which has to derive n. Okay. Now, once it derives n and once the hash is also calculated, what you have to do is very simple. See, before the hash, sorry, my bad, before the hash is being calculated, in this calculation, this particular wallet's rand function will get activated and it will add its own Kelsey also. So suppose n is 3, okay, and Kelsey is equal to 2 plus 1. Okay, so now this rand function will add plus 1 minus 1. So here 3 is coming, the deriving is 3 only. We are just trying to derive 3 from this equation, but this extra plus 1 minus 1 will make a different hash. So if hash is different, the quantum computer or any other system will say that, hey, the hash is different, so maybe the calculation should be different. There will be not 3, there will be something else derivative, and they will trap into this fall. They will literally fall into this trap that keep on calculating, but this rand function will eat them up. No amount of power can beat this rand function. And you know why? Because here is the gist of it. I will share the secret also. You can pair this particular thing with atomic clock, and you can put a step into it. So step 1, step 2, step 3, whatever amount of step you want to put, the precision of picosecond. So every picosecond, this particular thing will be different. Every picosecond, this particular thing will be different. The hash will be different. So every picosecond, the hash will be connected to that particular device. And if I say connected and logged, that means that this is your core. See, this is your core Kelsey. Your Kelsey won't change, but with rand you will have a new the derivative will be same, but you will have a new hash, a new function for obfuscation. Just like while signing a blockchain transaction, randomly the nonces are added. The same thing is happening over here. But here is the catch: whenever the rand function will perform this kind of entropy, or I can say this kind of calculation, what's going to happen? It will also log offline in your wallet. It will log offline what kind of calculation it has performed. It will keep that ledger, and it will encrypt the ledger in your previous hash, your public key. It will encrypt it, and whenever you are able to solve this particular Kelsey, definitely your Kelsey, your calculation, so this will be unlocked. And you will have to just step back and erase everything. You have to step back, erase everything, and you will have to find, you will have your original set of private key. So to obfuscate and to use the deceptive measures, we have done so much brainstorming and research, and I can say that this concept is still a baby because it has to be refined in a lot of terms. But this how you can I can say overcome the challenge of quantum computation or quantum supremacy. So in a nutshell, you can derive a finite equation from infinity and still be unpredictable, still not be a set of finite amount of rules or finite amount of numbers. You can still be infinite amount of probability, but without any starting point or without any set of directory. How cool is that? Because the main problem with ECDSA is also good. See, the nonces and entropy is all about the similar kind of things also. But the main problem is, I'll share something with you. See, whenever, see, this is the main problem. This is the barrier. See, there is some finite amount came. Okay, the other barrier I will share is this. Suppose if we generate a new hardware wallet, okay, you are saying that, hey Jay, you know what, there are tons of nonces and that of nonces, everything is fine, but what does it concise to? You know, whenever you whenever you shrink the very strong architecture of nonces and entropy, this is just damn character like 32 64 bit characters, 32 64 128 bit, and this is just a combination of A to Z, small letter, capital, and numbers. Dude, don't you think quantum computers can break this, can predict this? Currently we do not have it, because I mean, it just like imagine 10 years ago we used to have 10 GBs and 512 MBs and all of that hard drives, and now I'm using 15 terabytes of hard drive, a portable hard drive of 15 terabyte. Can you imagine the shape shift? At that time you could have thought that, hey, 15 terabyte would be the entire of internet, you know, or my life will go on into 15 terabytes. But currently, I mean, I have to purchase like 15 terabytes worth of hard drives to make sure that my data is intact, my research is intact. So this is all, guys, this is all. I mean, I would not like to hammer the theories more into that. Yesterday was very, you know, entertaining thing because it was all about cryptos and, you know, finance aspect of it. But today I went a bit technical to make sure that you guys are informed very well and you guys are can be a part of the research that we are doing. So that was all about it. You know, ask your question. See, whatever question you have, you can freely ask me. And again, I would like to say, do not trust ever. Verify. Never ever trust. So even if I say, hey, this is a quantum proof mechanism, you don't need to trust it. Just put your own hypothesis, put your own theory, and let me know. Because even whenever if someone want to contribute in the private and if they want to be a part of us, then we can definitely share the entirety of it and to clear more fuzz around it. But the basic principle of quantum proofing the technology is very simple. The derive, I mean, the probability of a equation is infinite. There is no finite set of rules. There is no finite set of equation. So in a nutshell, if you have the fastest car in the world, but it does not know where on which direction the destination is. Suppose you have a Tesla car in the space, or you have the best speed of light rocket on the space, but on some random x you have kept the reward. So on what x it should go, you know, it should go in the x, it should go into the yx, it should go into zx. On what multi-dimension is the space it is, right? It has really big amount of dimensions, and at what dimension you can cover, because if you have a lot of speed, right, and if you misdirect yourself, then you are going further and further to from the destination. So the point I'm trying to prove is speed not always overcome the scalability and the mathematic mindset or innovation, you know. So we can definitely win this race by creating this kind of infinite solution, because what do we refer as computer is just you know, calculative power. But if we put some equation which cannot be calculated, like infinity, not be calculated means cannot be predicted, which can be brute force and encapsulated in very finite set of rules. Cannot, you can't do that, and that's where you win. So I hope that was a really amazing thing, and I hope that you guys could get something out of it. And if you guys have any more question, do let me know. I'm all yours. And thanks for tolerating me once again. Whenever I'll get the opportunity, I will again share more and more information, more and more insight. So signing off from now, but I will still be here. Do send me the mail, do send me the messages, and I'll be more than happy to respond.
Jay sir, thank you so much, sir. It was a wonderful session, and like you, from your side, you tried maximum, sir. We can see you use whiteboard also, like, almost like it is a classroom. So it was a very nice session,
Yeah.
sir. So much. Uh, yeah, it is very nice, sir. Really wonderful. Thank you.
Yeah, I'm happy that I could provide any value to you guys, because to fight this quantum supremacy thing, we have to step up. And I'm not suggesting some solution which is very like it will cost you millions of dollars. I'm saying that with 6,000, 7,000 Raspberry Pi, na, if you implement the scientific protocol of mathematics, you're gonna beat these guys, because very simple psychology is, I mean, very simple calculation is, there is no finite set which any system can predict. And this is, I took very simple example to comprehend that 1 plus 1 7 8 3. But if you take like hundreds of thousands of character, the quantum computer will go nuts, that where to start, where to end, what to derive, they don't even know. Because here the secret is not shared, you understand, the secret is not shared. What is shared is just the calculation, just the authentication. So that's what is the gist of blockchain, that secret is never shared, the pre-authorized transaction is shared, and that's what we strive for. So yeah, that's what we believe in. It was a pleasure.
Yeah.
Thanks a lot for inviting.
Yeah, sir. Thank you so much, sir. I think our no question I can see. I think our there
Yeah,
may be a problem. Okay, sir. One something NBA 560. There may be a problem with protection of log. So I don't know. I did not understand. Probably you can understand, sir.
definitely. Is it on the chat? Should I look on the chat?
Yes. It is in the chat. I did not understand actually because I did not go through the presentation.
Okay,
Maybe you understand.
just a minute. Let me just have a look towards that. Just a minute. Okay. NB560. Oh
Yes.
yes. So NV560 is saying that logs need to be protected again from quantum. Yes, it's really wonderful thing that you have said, NBA 560, sir, that log has to be protected from quantum. Okay, now I'll tell you something. Whenever this, you know the concept of soft wallet and hardware wallet, right? Sorry, the hot wallet and cold wallet, right? Now, if you put the critical part in the cold storage, right? Uh, it cannot be predicted. What I'm saying is, whatever the blockchain and verificational thing you have to do, you don't need to put all the logs and all the iteration that you have done with the calci functions. What you have to put is the abstract of it, to just make sure that this is what defines you. This is what is your public key, this is what is your derivative, this is what is your hash. And as it cannot be turned backwards, your secret is secured, and your secret cannot be shared with anyone, and no one can predict it because it will be very offline. And if you make certain air gap technology, like I'll share you a very simple thing. There is a application called file gap in the Mac OS, that with which you can type any amount of string and it will convert it into the QR code barcode, and you just need to scan it to the other device. So you don't need to even transport your data over there. It will be just very graphical information be transferred. So here, if you try to manage, if you try to protect your secret in an offline environment, then there is nothing to worry, because as I said, it cannot be predicted. Only if it is leaked, only if any instance of this is leaked online, you are messed up. You are literally messed up. But to overcome that, I am designing my own hashing system in which, suppose, what happens with the MD5, right? I'll share a very simple thing. See, I'll share my screen and I'll share you one very simple example. What are the problem with the current hashing function, whatever it is, be it SHA, okay, online. Okay, let me share one thing. See, the current hashing system, why we are generating our new hashing system is that, suppose if I type like 5, okay, so the 5 hash will be only this. Again, if I type 5, see, the hash will not change, you know. If I type 67, see, the hash is this. See, so it does not matter how many times I type 67 or 5, because 5 have a very, I can say, static set of encoding. Because of that, the hash is the very static. But what I am trying to generate is a dynamic hash. And how you can generate a dynamic hash? By taking the initiatives start time of the clock, the atomic clock, that currently the clock is in the position of 0 1 2 3, whatever the timestamp is. So you have to log the timestamp offline in your software, offline software. And then from there, once you start it, it will be a picosecond, my friend, not even a like blink of an eye. The whole hashing directory will be changed. So if I type 67 right now, this is 75e, whatever it is. But now if I type 67 into my hashing functions, once I get patented, I will publish it definitely. So this will be not similar. The hashing function will also change, and every time the clock iterates, you know, now you know the clock pattern because you have deployed it offline. So basically, only you as a owner can go back and see the all the iteration of the clock and go back to that state, or the first initial state. But if there is any other quantum system, or if any other man in the middle attack, they cannot do anything about it, because they do not know the very basic starting point of that particular clock. So when there is even you know what, L'Hopital rule, right? It can define the infinite equation from infinity, because it is 0 0 into 0 if you do, or 0 divided by 0 you do. Here the value of 0 is not changed throughout the equation of limit. 0 is just 0 only. But in our equation, the time is constrained. And I will specify that also, that this is just a quantum encryption and decryption system which I'm sharing. But in future, we are also going to launch the stable coin, which is literally stable, which have just one constraint, which is time. Because you, me, and Mr. Gates have one thing in common. That is, my 1 second is the same your 1 second, same Mr. Gates 1 second, until we all are accelerated to the speed of light. And that's not going to happen any sooner. So as now, to fight this battle, to win this battle, we are innovating this. So I hope that answer your question.
Hello, Jay sir.
Yeah.
It's a very nice presentation. Please tell me something about off-chain wallet.
Okay, off-chain wallet means, I mean, you're talking about the off wallet, like a cold wallet or air-gapped wallet?
That is the confusion actually lies. On-chain wallet, off-chain wallet. On-chain wallet may we
Oh,
say hot wallet and cold wallet,
yes.
according to some
Okay, okay,
research paper.
okay. Let me make it very simple. See, so basically, see, off-chain wallet and on-chain wallet are different things than hot wallet and cold wallet. We have to understand very basic. That is really wonderful question, I must say, because no one should be confused like this, because this is very common confusion I get with all the other students as well, that hey, off-chain wallet, on-chain wallet, and then this. Okay, are you aware about the lightning node?
Lightning node.
Lightning node of Bitcoin, like Bitcoin is not natively lightning supported. Like, so I'll give you a very simple example. Let's go from very basic to solve all the confusion. See, what happens is, if I transfer the Bitcoin right now to you, right, it's going to go through the mining process, and it will take like 1 minute, 2 minutes, 5 minutes, 10 minutes, or up to an hour. it's taking tremendous amount of time from ASICs to mine this whole transaction. So the community has built wonderful solution that is known as a lightning communication, lightning solution. In the lightning wallet, what happens is that for say you daily go to the coffee shop, okay, so you will not have an on-chain contract, you will have an off-chain contract. Means for say you go to Starbucks, you buy $5 coffee, so you will deploy a lightning node which is not yet kept on the blockchain. Okay, see, on-chain means whatever transaction is done immediately it's broadcasted on the native blockchain. Now what you are doing is you're forking that whole thing. I mean, I cannot say you're forking, you're just making your own peta node, and that particular node will be a lightning node which will also facilitate all these transactions. Okay, but it will create a smart contract, whereas all the daily transaction, all the micro transaction need no blockchain mining as per now. When there is a big amount of block, like for $1 I will not spend my mining resources. When it clustered into a very big transaction, then only I will broadcast to the native blockchain. So that is used as a off-chain wallet. Like if you have a off-chain wallet, if you have a lightning node, then that will be off, that can be identified as an off-chain wallet, because lightning node does not actually connect to the native blockchain of that particular asset, but it creates their own set of nodes. And then once that node is substantial enough, like once that node is big enough to be uploaded on that particular
On.
it is very simple. See, if your private key is stored in hot wallet, I mean online, it's a hot wallet. If your private key is stored offline, it's a cold wallet. So it's very simple thing. I hope that answers the question.
Yes, sir.
Jai
Pretty
sir,
much.
Madam, I think we'll not be able to take more questions. I'm extremely sorry for that. We are running out of time.
It's okay,
So,
sir.
Jai sir, okay. Extremely sorry, madam. So, Jai sir, thank you so much, sir. Our expert also waiting. So, we'll take a rest for another some 15 to 20 minutes. And
Okay.
sharp 11:30 or 11:35, we'll be coming back. I request all the participants to join by 11:25. Thank you so much, Jai sir. Once again, it was a very nice presentation. We'll meet soon, sir. Thank you so much. And I
For
request
sure,
all the
for sure. It was a
to
pleasure.
join by 11:25. Thank you so much. Thank you all.
Thanks a lot for tolerating me. Okay. Have a wonderful time.
Thank you, sir.
Keep the
Thank you.
blockchain alive. Yeah. See ya.
Yeah. Thank you.